Okay, let's go through 14, 15, and 16. These are the word problems on the review. Pause when you need to, rewind and re-listen if you need to, and yeah, so let's go. All right, 14, Harry and Melanie are working on cleanup detail. Harry cleans up the trash in his area in 6 hours, so that's his time. So what we need to come up with is, what is Harry's rate? Okay, so if he can do the entire job in 6 hours, that means he can do one job per 6 hours, which is 1/6 of the job per hour. Melanie can do the same job in 4 hours, so her rate, that means that she can do one full job in 4 hours, which is 1/4 of the job per hour. Okay, so that's 1/6 of the job per hour, and this is 1/4 of the job per hour. Now, if they work together, how long will it take them to clean that area? All we have to do is rate of Harry, since they're working together the exact same time. Rate of Harry plus rate of Melanie equals the total rate. Okay, so the rate of Harry is 1/6, the rate of Melanie is 1/4, and the total rate will be 1/t. Okay, and we're going to solve for t, and you can do that by adding your fractions on the left by adding the 1/6 plus 1/4. So we get 5/12 equals 1/t, cross multiply, and the time if they work together is 12 divided by 5 hours, which, if we look at that, is 2.4 hours. Okay, so that's one way of solving it. The other way is comparing the work. So rate times time of Harry plus rate times time of Melanie equals one job completed. Okay, so work plus work equals work. So the rate of Harry is 1/6. We're looking for t. The rate of Melanie is 1/4. We're looking for t, and we're going to set this equal to work, which is the one job completed. So we add 1/6t plus 1/4t, which gives us 5/12t equals 1. To solve for t, multiply both sides by your reciprocal. And that's how you can see that you also get 12/5 or 2.4 hours. Okay, so you can see working together will definitely speed up the job. 15 is the same type of setup. We have, their job is to complete the washing of 500 plates. Okay, Ron works as a dishwasher. He can wash the 500 plates in 2 hours and 15 minutes. So you need to make sure you're paying attention to units. So 2 hours and 15 minutes is 2.25 hours. Okay, so you have to make sure you're in the same units for both times. So since that's just 3 hours, we don't want to convert that to minutes. So Ron's rate, he can do the one full job in 2.25 hours. In the rate of Chris, he can complete that one job in 3 hours. So that means in the 1 hour, he can do 1/3 of it. So if we're looking at rates, rate of Ron plus rate of Chris equals rate of the job. So I'll just say total rate. So that's 1/2.25 plus 1/3 equals 1/t. And you can add the left hand side together by getting a common denominator and adding, and you get 7/9 equals 1/t, cross multiply, and the time will be 9/7 of an hour, which is approximately, this will be rounded, 1.286 hours. Okay, so you can see that shortens it up. If you do it using work of one plus work of the other equals the total work, that would be rate of Ron times time of Ron plus rate of Chris times time of Chris equals one complete job. Again, they're working the same time, so that's what we're trying to solve for. The rate of Ron is 1/2.25 The rate of Chris is 1 over 3. When I add those together, I get 7/9 t equals 1, and then multiply both sides by the reciprocal of 9/7, and that's where you get the 1.286 hours. Okay? Number 16, the last one. Now, this is their times are different, so we're going to have to just go the work approach. Okay? Brad can mow a lawn in 3 hours less than Don. So Brad's time is 3 hours less than Don. So if we write it as x minus 3, that means Don's time is x, okay? If you were to say that Brad's time is x, that means Don's time is 3 more than Brad. So either way, you can do this. It does not matter. It just means in the end, if you do the ones in blue, X represents Don's time. If you do the ones in red and solve, X will represent Brad's time. I'm just going to go with the first way I wrote it, where X is for Don's time, which means Brad's is 3 hours less. So we're going to have to do rate of Brad times time plus rate of Don times time equals 1 complete job. When they work together, it takes 2 hours. So we know the time when they work together. That's not what we're solving for. So this is a little bit different. We're solving for how long it takes them to do the work by themselves, okay, the full job. So the rate of Brad is 1 over x minus 3. The rate of Don is 1 over x. When I combine those, this is what I get. And this one, I would say probably go back to the way we solved last week. Get a common denominator. So I'm going to multiply this one by x over x, this one by x minus 3 over x minus 3, and then the one by x over x, or x times x minus 3. Okay, so when I do that, I get 2x plus 2 times x minus 3 all over x times x minus 3 equals x times x minus 3 over x times x minus 3. And once you have the common denominator, remember, you can just cross it off. You can show your work by multiplying both sides by the LCD, however you want to. I'm just going to cross it off because it's the fastest. In the simplifying process, I am going to distribute here, and I'm going to distribute here. You can see you have a quadratic, so we're going to set this equal to 0. I'm going to subtract 4x from both sides and add 6. I'm going to factor. And when I solve this, I get 6 and 1. So obviously we know here we're not going to have two different answers. So we have to check and see if it makes sense. So let's say if x equals 1, that means Don's time is 1 hour and Brad's time is 1 minus 3, which is negative 2 hours. That doesn't make sense. You can't have a negative time. So that's not going to work. So let's just make sure x equals 6 works. If x equals 6, Don's time is 6 hours, and Brad's time is 3 hours less. Okay, so 6 minus 3, which is 3 hours. That does make sense.